Hello my dear students, this is Akash HD. Welcome to the ASD physics classes. Hope so you all are doing really great. So students, in this video we are going to solve the questions based upon ground to ground projectile motion. Okay, let's start. So here you can see first question. A ball is projected from point A with velocity 20 meter per second at an angle 60 degree to the horizontal direction. At the highest point B of the path, as shown in figure, you can see the velocity V of the ball will be how much in meter per second. So here you can see very well from point A, the ball is projected with how much velocity U, how much angle theta. Now at the highest point B, you know what will happen? The vertical component of the velocity will be 0 and the horizontal component of the velocity will be constant because there is no air resistance. So here you know very well at the projection point horizontal component is what? U cos theta. So here also the horizontal component of the velocity will be how much here? U cos theta. Is it? After that, if I talk about here what data is given here, you can see very well the U is given here 20 meter per second, is it? And theta is given here 60 degree. Now, so we can tell very well at the highest point the horizontal velocity is a U cos theta. So 20 into cos 60 degree. Cos 60 degree how much here? 1 by 2. So what will come here? It will come here 10 meter per second. Is it? So we can tell very well at the highest point horizontal velocity is 10 meter per second and the vertical velocity is how much here? 0. And even the resultant velocity is the 10 meter per second. That is the combination of the horizontal and the vertical velocity. Okay, let's go to the next one here. See. A bullet is fired from a gun at the speed of 280 meter per second in the direction 30 degree above the horizontal. The maximum height attained by the bullet is how much here? Okay, so here also you can see very well from the ground to the topmost level is called what? The maximum height. So here if I talk about here the data is given what here? The data is given here. U is the 280 meter per second. Angle is given here what? 30 degree, and we have to calculate here the range now, and the G value is also given now. So remember that here the range formula, not range actually, we have to calculate what? We have to calculate here the maximum height, is it? So maximum height we have to calculate now. So you know very well the maximum height formula is H equal to U square sin square theta by 2G, is it? So U what is given here? 280 square here. Okay, so see 280 square into sin square 30 degree. So we'll write here sin square 30 degree by 2 into 9.8, is it? After that, you know what will happen that here 280 square, even I can write here, see here 90 into 4 and here also 90 into 4, and sin 30 degree what will become here? Sin square 30 degree 1 by 4, and here I can write here 2 into 9.8 here, is it? So here what will happen that here, kindly see very well, this 4 and this 4 will cancel out, is it? So after that we can write here, just simplify this here, see this 2 into 2, 4. So from here I can write, just see very well, this 10 and this 10, 20 into 10, how much here? 200. This is 200 will come here, and here what will come here? See here 9 and here 9, it will become here 49 by 9.8, is it? So 249 by 9.8, it will come 5 here, is it? So when you will simplify this, it will come here the 1000 meter. You can do the calculation by your way also, not a problem. And range also you can calculate as I have written in the starting range formula U square sin 2 theta by G, that we will see in further questions also. Now let's see. The next question is what? See here. A projectile is fired from the surface of the earth with a velocity of 5 meter per second and angle theta with horizontal. Now, another projectile fired from another planet with a velocity of 3 meter per second at the same angle follows a trajectory which is identical with the trajectory of the projectile fired from the earth. Trajectory is identical. Okay, now see the value of acceleration due to gravity on the planet is how much here, is it? So for that what we have to use? We have to use this trajectory formula. Na? This is the equation of trajectory that is called here. So in this equation of trajectory, you know very well the theta is constant, is it? Theta is constant and full identical trajectory. That means y and x is also constant. So here you know what will happen that here this G by U square will be what? Constant, because both the trajectories are same, is it? So what can I tell here? I can tell very well here, G planet by U planet square will be equal to G on earth by U earth square. Okay, so from here the gravity on the planet is given by, remember that here I can write here GE into UP by UE whole square here, UP by UE whole square. What is GE? That is given here the 9.8. Speed on the planet, what they're telling that here, 3. So 3 square means it will become here the 9. Okay, and on the earth how much speed is given here, C. So 5 square will become here the 25 here, is it? So 9.8 into 9 by 25. When you will simplify this approximately, it will come here the 3.5 meter per second square. That is the gravity on the another planet here, is it? Because remember that here, this is the UE now, and this is the UP now. Speed on earth and speed on the planet initial here, is it? Very basic question. In this kind of question, G by U square will be what? A constant. Remember that here. Okay, next question, let's see here. The velocity of a projectile at the initial point A is 2I cap plus 3J cap meter per second. Its velocity at point B is how much here? Okay, so remember that here, this is the point A and this is point B. So what is the velocity at point A? 2I cap plus 3J cap. So in horizontal direction 2, in vertical direction 3, is it? So 2I cap plus 3J cap. Even if I tell here the speed at point A, this will come here what? Square root of 2 square plus 3 square. What will come here? 5 meter per second, is it? Now something extra he told you. Here what will happen right here? When it will strike the ground, the horizontal component will be what? 2. But now when it will strike, the velocity will be downward direction like this. Like here we have projected upward, na? Like it will strike, when that time velocity will be downward direction here. So it will have one component 2 horizontal and one component 3 vertical, is it? So if I write here the velocity at point B here, now let's take here, I have written here UB, no problem. So UB will become what here? Kindly see here, 2I cap plus 3 minus J cap here, is it? So which option will be correct here? 2I cap minus 3J cap. Even if I talk about here the magnitude also, UB is equal to, you can see very well, 2 square plus minus 3 square, and what will come here? 5 meter per second. So you can see very well at point A and at point B, what is happening that here? Speed is same because there is a no air resistance, but the velocity is different. Why? Because the direction is different here. Okay, can you see very well? Answer is the option A. Okay, next one, let's see here. The horizontal range and the maximum height of a projectile are equal. The angle of projection of the projectile is how much here? Okay, so remember that here in the question they told you the range is equal to maximum height. This they told in a question. So for that we should know one thing very well. Remember that here, even previous video also I have taught you, if r equal to n times of h, then you know what will happen that here, in that situation the angle of projection, that means tan theta, that means when we will project from here with the speed u, making angle theta, is it? So this tan theta is used to be, remember that here, 4 by n. Okay, so if you compare this one and this one, so what will happen that here, the value of n will come here 1. Is it? Because r equal to nh, r equal to h, so I can write here 1 into h. So what is the value of n? 1. Just put here, when you will put the value of n is 1, so it will become here what? It will become here 4 by 1. So hence theta will come what here? Theta will come here tan inverse 4. Now very right formula is there here, is it? So where is the option is there? The correct option is here, option B is the answer. Kindly see very well, is it? Next one, let's see here, this question. A missile is fired for maximum range with an initial velocity of 20 meter per second. If g equal to 10 meter per second square, the range of the missile is how much here? Okay, so we are asking here the maximum range. Remember the formula here, the range formula is what? U square sine 2 theta by g. This is the range formula. Okay, and if we have to calculate the maximum range, so for maximum range, remember that here our theta value is used to be always 45 degree, then only sine 2 theta will become 1. Okay, and in this situation this maximum range will come here r max equal to u square by g, because sine 2 theta how much here? 1. So u square, what is given here? What is the value of the u? You can see very well the u is given here the 20, so 20 square, 20 into 20. G value, let's take, I have taken here 10. So when I will take here the 10, see this 0 cancel. So 20 into 2, it will come here what? Here the 40 meters. So maximum range is coming how much here? Option A is the answer. Remember that maximum range is possible at a 45-degree projection angle only. Next question, let's see here. A projectile is fired at an angle of 45 degree with the horizontal elevation angle of the projectile at its highest point as seen from the point of projection is how much here? Okay, so in this situation, the angle of projection, what is given here, you can see very well the angle of projection, they are telling here 45 degree. Okay, so remember that here when one observer from the projection point will see the highest point, this will be the line of sight. So this line of sight is making how much angle from the horizontal? Phi. Okay, and remember that here this is the maximum height h and this used to be the r by 2. So we can tell very well tan phi equal to h by r by 2. Okay, but I will tell you direct formula. This tan phi is equal to how much here? H by r by 2. But when you will put all these values and all that here, directly formula I have told you to remember in a previous video, tan phi equal to half tan theta. That means half into tan theta, how much here? 45 degree here, is it? So from here phi will come what here? Phi will come here tan inverse and tan 45 1 only, so it will become here the 1 by 2. So phi equal to tan inverse 1 by 2 is where the correct option is here. Option B is the answer. Remember the formula, tan phi equal to half tan theta, phi is angle of elevation, theta is the angle of projection here, is it? Next one, let's see, the question is, a particle of mass m is projected with velocity v making angle of 45 degree with the horizontal. When the particle lands on the level ground, the magnitude of the change in its momentum, how much here? Okay, so what will happen that here, when the particle is projected from here, is it? So here we can tell projected from point O and here reaching at point B. So when it will land at the ground, then what is the change in momentum? So I can tell very well, remember the formula, the change in momentum delta P between which points I am telling that here, between point O and point B. Okay, so B is the final point, O is the initial point. Directly formula is there 2 mv cos theta. Okay, I have taught in a first video here. Okay, 2 mv cos theta, where m is the mass of the ball and v is the projection velocity. 2 mv cos theta. So 2 mv, what is the projection angle? What is given here? The 45 degree. Okay, cos 45 degree. This is the projection angle. So cos 45, how much here? 1 by root 2. So when you will simplify this, it will come here root 2 mv. What is coming here, students? Here root 2 mv. Correct option. The correct option is here. Option A is the answer here. Is it? Great. Now let's see the next one. Here you can see a ball of mass 100 gram is projected with velocity 20 meter per second at 60 degree with horizontal. The decrease in kinetic energy of the ball during the motion from point of projection to the highest point is how much here? Okay, so as I have told you in a previous one, projection point O, highest point is B, is it? So at the projection point, what will happen that here? We can write here the energy is given here half m. Let's take initial speed is the u, so half m u square. Okay, at the highest point I have taken here point A, is it? You can see here also, see this one here, I can tell this is point A. Okay, and this is point 2, I am telling that here. Okay, so at point A, what will become that here? See, half m, and you know very well, even in the first question I told you, at the highest point, what is the velocity? U cos theta in the horizontal direction. Even speed also u cos theta, because vertical component is the 0. Okay, so this will become what here? Half m u square and cos square theta. Theta, how much is given here? 60 degree. 60 degree. Cos 60, 1 by 2. So I can write here 1 by 2 square. It will become here 1 by 8 mu square. Okay, now in the question they are asking the change. Remember that here this energy is used to the minimum at the highest point. Now, so change they are asking. So k naught minus k will become what here? Kindly see, half m u square minus 1 by 8 mu square here. Okay, so when you will take here the LCM and all, it will come here 3 by 8 mu square. Take mu square common outside here. So half minus 1 by 8. Now, so when you will solve 4 minus 1, 3, 3 by 8 mu square here. Okay, so see here now this is 3 by 8. Mass, how much is given here? 100 gram. Is it? Convert into the kilogram. So 100 by 1000 here. Is it? Into u square. U, how much is given here? 20, 20, 20. So 20 square means it will become here the 400. Okay. So after that, we'll just simplify the things and all that here. This 2 0 cancel, this 2 0 cancel here. This 1 0 cancel, this 1 0 cancel is there. Okay. So we can write here 8 5 ja 40, 5 into 3, 15 joule here. The change in kinetic energy will be how much here? It will be 15 joule. Remember that here. Is it? Great. Next question. Let's see. The question is, a particle is projected with velocity u so that its horizontal range is 3 times the maximum height attained by it. The horizontal range of the projectile is given as this one. What is the value of the n? Okay. So remember that here in the question they are telling that here r is a 3 times of maximum height. R equal to 3h they are giving, is it? But what I have told you very well, when r equal to nh, is it? So in this situation, what is the tan theta? Tan theta is the 4 by n. But what is the value of the n when you will compare here n and here 3, is it? So I can write here tan theta is what is coming here, 4 by 3. What is tan theta? 4 by 3. So even I can draw here one triangle also. See here, opposite by adjacent. This is 4, this is 3. If 4, this 3, this will be what here? 5, and this is the angle theta, is it? So see, I have drawn here one basic triangle. Now if I write the value of the range is given here what here? U square sine 2 theta by g. So see here, u square sine 2 theta means 2 sine theta into cos theta by g, is it? Sine theta cos theta value will put from here. Okay, so first let's see here, u square is as it is. So see here, u square by g into 2, is it? Sine theta, that means sine theta what will come here? You can tell opposite by hypotenuse. So it will become here the 4 by 5 here. Cos theta what will come here? Base by hypotenuse. So it will become here the 3 by 5. So when you will simplify this, 4 into 3, 12, 12 into 2, 24. So it will become here 24 u square by 25 g, is it? So you just compare here n is coming and here what is coming here? 24. That means what is the value of the n? The value of the n is very easy, 24. The value of the n is what here? 24. Is it?